Hello everyone, welcome to the series of O-Level Mathematics Class 9-1 Cambridge IGC SE syllabus. So we are doing the concept of functions, and in our previous lectures we studied functions, we studied inverse functions, and in our last lecture we studied composite functions, and we did exercise 21D of Collins' book, which is about the composite function. In today's video, we will learn about composite function mode, and we will see more advanced questions of composite functions which are coming in the O-level exams. Okay, before this, if you didn't like our channel, please like and subscribe and share with others. Thank you. Now let's go to our exercise 21.4, which is more about composite functions. Previously, we learned two things of in 21.3, that in exam there are two types of question that can occur, right? First type of question is we have given two functions like f of x, take it as x square, and g of x, left take is x minus c. So in first type of question exam, we are given two functions f of x and g of x, and we have to ask to evaluate composite function at any given value. So like f g of 3, right? So in exam, we are given f of x, g of x, and we have to find f of g of 3, or at any value f of g of 4, f of g of 7, or any other thing. Or here we have f of x square, g of x minus 3. In exam, there can be any other function, but the method remains same. Okay, so we see that how to do this question. So we'll just read this thing from right to left. So first thing is here is g of 3. So first we have to find g of 3. So g of x is x minus 3. In place of x we write 3. So 3 minus 3 is 0. So we find g of 3. Now actually we have to find f of g of 3. So g of 3 we know now it is 0. So actually we have to find f of 0. Since f of x is x square, so f of 0, 0 square. So it is 0. So this means f of g of 3 is 0. So this is the first type of question which can occur in exam, that you are given any two functions. Here, for example, we take f of x square and g of x minus 3. And then they have to find, give us to find composition function. So whenever two functions written like this next to each other, it means there is a composition, right? So this means this term tells you that, okay, you have to do a composition. So f of g, and you have to do this composition for 3. So the way to do it, to read it from right to left, find g of 3 first, then put in f and find finally f of g of 3. So this is first type of question that can occur. Another type of question is something more general, which is the second type of question and can occur in exam like this, that you have given. Again, let's take the same example, f of x square and g of x is x minus q, x minus 3. Now instead of finding any particular value, they have to find f of g of x, right? Or g of f of x. So this is a composition and this is composition. So for two function, we can make two composition. First step, then g, in the next one, first g, then f, right? So now in the second type of question, they can ask that find generally f of g of x, composition of f and g, or they can ask composition of g and f. So g f of x. So for this, we learned that for f of g of x, like, so we have f of x. So if we have to find this f of g of x, so take f of x, which is x square, and it, because you have to find f of g of x, So take f of x and instead of x, in place of x, write g of x. So this thing become f of g of x, and here g of x is 1. Okay, so f of g of x as it is in the left hand side, and here in place of g of x, write value of g of x, which is x minus 3 of this. And then you have to simplify it further. You can see x minus 3 means x minus 3 square. So a minus b ka whole square, a minus b whole square, which is a square minus 2ab plus b square. So we write it as x square minus 3 into 2, 6x plus 3 square is 9. Right? So this is f g of x. Now, the second thing to find g of x. So for g of x, you have to write first g of x, which is x minus 3. Now in place of x, write f of x. So it means f of x minus 3. And here left hand side remains same. And in the right hand side, put the value of f of x, which is x squared. So x squared minus 3. So this is two types of questions we learned in 21.3. So in 21.4, the concept remains same. These two types we know. And in this exercise, we have solved again the type of questions is remains these two, this one or this one. So question in the exam can occur in these two types from the composite function concept. But in this exercise, we learn some advanced question about this type and this type also for both types, this one and this one. Okay, so let's start exercise questions. So there is nothing new in the exercise. We just have to do advanced question of these two types of composite function questions. Okay, now let's start exercise 21D. So here we are given the question that f of x is x minus 3 over 2, g of x is 3x plus 1, and we have to find these values of part A, B, C, D. So you can see this question is from type 1, first type question. Why first type? Because here we don't need to find a general expression, but to find the value of this composition at particular value 3, 6, 5. So let's do part A. So in part A, we have to find f of g of 3. We have to find this. So we read it again from right to left. So first g of 3 we have to find. So g of x is actually 3x plus 1. So g of 3 is 3 into 3. So in place of x, I write 3 plus. So g of 3 is 10. Now we have to put this 10 in f. F of x is minus 3 over 2. And we have to find f of g of 3. So it means in place of x, we have to write g of 3. So g of 3 we know is 10. So 10 minus 3 over 2. It means 7 upon 2, which is 3.5. And the part is 10. Let's do part. I am doing part D. Part B and C are same as A and D. So do it by yourself. So in part B, you have to again find g of 3. G of f of 3. Now first put 3 in f, find out the answer, and then put this answer in G. Okay. And D is the same as B, A is same as C. So I did A, you can easily do C, right? I did this, just put 6 in place of 3, right? In the same thing. Now I'm doing part D. Part B is same as D. So let's see part D. So G f of 6. So we have to find this. First we have to do right hand side this f of 6. So f of x is x minus 3 upon 2. So it means f of 6 is 6 minus 3, which is 3 upon 2. Okay. Now g of f of x, f of 6, which means g of f of 6 means 3 upon. So we actually do g of 3 upon 2. So g of 3 upon 2, because g is 3x plus 1. So 3x, x is 3 upon 2 plus 1. So it is 9 upon 2 plus 1. And always do the calculation complete, i.e. you have to write, take this LCM. So this is 1, 2 1 the 2, 1 into 9 is 9, 2 into 1 is 2, so 11 upon 2, which is up, which is 5 points. So part A is complete. B and C, AC is same as A and B is same as D, so you can do by it yourself. Okay, so part 2 is same as part 1, so did it by yourself. Do part question 2. Question 2 is same as question 1 of exercise 21D, so do question 2 by yourself. Now let's do question 3. So for question 3, we have to ask that this is f of x, which is 2 raised to the power x, 2 to the power x exponent. G of x is 2x minus 1. We have to find g f of 2. Okay, so g f of 2 we have to find in part A. First we have to find f of 2. So f of 2 is, since f of x is 2 raised to the power x, so f of 2 is 2 to the power 2, because f of x is 2 to the power x. So we write x in place, 2 in place of x, 2 to the power 2 is 4. Now g of f of 2 is, g of f of 2 means g, f of 2 is 4. So we have to find g of 4, g of 4. G of x is 2x minus 1, so g of 4 is 2x, 2, 4, 1. So it 8 minus 1, which is 7. Again easy. Part B again. So let's do part B as well. F of g of 2. So now we have to first find g of 2. G of x is 2x minus 1. So g of 2 is 2 into 2 minus 1, which is 3. So g of 2 is 3. Now, f of g of 2 means f of 3, because in place of g of 2, I write its value of 3. F is 2 to the power x, so f of 3 is 2 to the power 3, so it is 8, because 2 to the power 3 means 2 multiplied by 2 multiplied 2 to the 4, 4 to the 8. Okay, part C is f3. So f of 3. So we have to apply f twice, because we have to read it like this. So we have to find this, we read it right to left. So first we have to find f of 3. F of x is 2 to the power x, which means f of 3 is 2 to the power 3. 2 to the power 3 is 8. Now we find f of 3, but we have to find f of 3. Right? So this f of 3 we already find, it is 8. So f of 8. So actually we have to find f of 8. Again, f of x is 2 to the power s, so f of 8 is 2 to the power 8. 2 to the power 8 is 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2, 1, 2, 3, 4, 5, 6, 7, and 8. 2, 2, 2 into 2, 4, 4 into 2, 6, 6 to the 12, sorry, 2 to the 4, 4 to the 8, 8 to the 16, 16 to 32, 32 to 64, 64 to 128, 128 and 2 to 56. The answer is 50. You can do in calculator as well, 2 to the power. Okay, let's do part G, part D, which is G into G of 6. So we have to apply G 2 times. G of x is g of x 2x minus 1. So g of 6 is 2 into 6 minus 1. So 12 minus 1 is 11. So g of 6 is right. Now g of 6 is 11. Now g of 6, it is equal to g of 6 we already know 11. So actually we have to find g of 11. So g of x is 2x minus 1 to 2 11 minus 1. 22 22 minus 1 21. So again. So the only thing is here which is not which is different from the previous question is this, that in question maybe you have to apply f more than one, right? So from f and g we can make four composite function: fg, gf, ff, gg, right? So four composite function we can make from two functions. Okay, so this question is complete. Okay, now let's do question 4 of exercise 21D. Here we have given two function f and g, and we have to find gf of x in part A. So g of x is g of x we have to write first, which is 2x minus 2. Then g of x we have to find, so in place of x I write f of x. So 2 f of x minus 2, right? So in place of x we write f of x. 2 f of x is 3x plus 1, right? Minus 2. So 2 into 3 is 6x plus 2 minus 2 minus 2 plus 2 cancel out. It becomes 6x. So g f of x is 6x. Part B is we have to find f of g of x. So f of g of x is nothing but just we have to find f x, which is 3x plus 1. Now in place of x we have to write gx. So 3 gx plus 1. So 3 as it is, gx is 2x minus 2 plus 1. Now 3 into 2, 6, 6x minus 3 into 2, 6 plus 1. Now 6x minus 5 is f of g of x. And this part is again complete. Okay, so we did question 4, question 5, 6, 7, 8, 9, all are same as question 4 and 3. So you have just to evaluate the value at some point or find the general expression, but the method remains same. So 5, 6, 7, 8, 9 all are same. So try it by yourself. Now we are going to do question 10. Question 10 is different from the previous ones is because we have given h and k, again two function, but in part A we have to find h inverse kx. Okay, let's do question 10. So in question 10 we have given hx and kx, but this question is different from the previous one because we have to find a in part A h inverse of k of x. So remember we did to study how to find inverse of any function in exercise 21.2 of inverse function of Coulomb's book, right? So here we are given h of x and k of x, but not h inverse. So first we have to find h inverse from hx. H plus 4 upon 2. Okay, so h of x is, first step is we have to replace h of x with y is x plus 4 upon 2. So this 2 goes there to 2y. So in second step, we have to find the value of x plus 4, which means 2y minus 4 equals x. Right, in part 3 now, just replace x with h inverse because we now find h inverse. and then part 4 replace y with x. So actually h inverse x is 2x minus. Now we have to find h inverse of k of x. So h inverse x we already found 2x minus 4. Put kx in place of x, which is k of x minus 4. So h inverse k of x as it is, take it as it is. Here in place of k of x, just write 3x minus 5. 3 into 2, 6x minus 10 minus 6x minus 40. This is h inverse kx. In part B, we have to find hx. So actually apply h of x 2 times. So h of x is what we are given as an h of x is x plus 4 upon x plus 4. Now we have to find h of x. So here in place of x, we have to put h of x. Right. So this x we replace with h of. Now this x is h of x plus 4 upon 2. So h of x is we are given h of x plus 4 upon 2. So this h of x I write plus 4 divided by 2. So h of x. Now we have to solve this numerator first. So 1, there is nothing, which is 1. So 2 multiplied by 1 is 2. 1 with x plus 4 is x plus 4 plus 2 into 4 into h of x is this. Now h of x is x 8 and 4 is 12. This is h of x. And the answer is no.